Hi all, this is Asma. Today we will have a look at an example for modulation and multiple access techniques. For this example, the 3GPP specifications for LTE related to the channel bandwidth and resource blocks are shown in the table below. So here we have the different channel bandwidth that can be served for any user equipment, and to each of this channel bandwidth we have the associated number of resource blocks. So for example, for 20 megahertz, we can have 100 resource blocks. So if a single user equipment takes a channel bandwidth of 20 megahertz, calculate the maximum achievable throughput if the UE use a 64-QAM modulation scheme encoding MCS with CISO and 4x4 MIMO antennas. Okay, so here we have a representation. We have a channel bandwidth and then the associated resource blocks. So for example, from the total channel bandwidth, okay, there's a usable transmission bandwidth configuration, and then there's also the transmission bandwidth which is used for resource blocks or the active ones. And if we have another look in a different angle for the resource block, what is actually resource block? Resource block is actually one slot of 0.5 millisecond, where it consists of 12 times 7 symbols. So we have 12 here on the side of the subcarriers, and then times 7 symbols, where one symbol occupies one resource element of 15 kilohertz. So if we want to know how many symbols per that resource block carries, we compute 7 times 12 times 2. So where this 2 comes from is from the fact that each resource block have a slot of 0.5 millisecond. But if we want to know the total number of symbols per millisecond, we times 2. So this is the result. We have 168 symbols per millisecond for each resource block. And then for a 20 megahertz bandwidth, where we have 100 resource blocks, we have a total of 168 times 100, which is 16,800 symbols per millisecond, or we can also call it 16.8 mega symbol per second. So here what we have is symbols, the number of symbols per millisecond. But what if we want to know the throughput, the data rate, which is always in bits? Okay, so we need to look at the modulation scheme. In LTE, we can either have QPSK, 16 QAM, 64 QAM, or in the best case nowadays, we can have 256 QAM. So in our exercise, in the example, in the case of 64 QAM, which is equal to 2 to the power of 6 actually, okay, sorry, QAM, then we know that we have 6 bit per symbol. Okay, 6 bit per symbol. Then the throughput becomes 16.8 times 6 to make it 100.8 megabits per second. So now we have the bits per second for any single chain. And in the case where we have accompanied MIMO technology, okay, so for example, in the case of 4x4 MIMO, where we have 4 transmission and then 4 reception, we take the throughput and times it with 4 to get a total of 403 megabits per second. And this is for the case of downlink. But there is a 25% overhead normally, which will be used for controlling and signaling. So the 403.2, we need to times by 0.75% only to get the final 302.4 megabit per second in the downlink, or more commonly said as 300 megabit per second. And then if we go to the uplink, okay, where we have only one transmit chain at the user equipment end, okay, so at the base station we have a MIMO, but here we only have one chain, and we have actually a throughput of 100.8. So after 25% off, we get 75.6 megabit per second, or more commonly used 75 megabit per second. So this is why, or this is where we always get the throughput 300 megabit per second on downlink, and then 75 megabits per second for uplink shown everywhere. So this is after taking into consideration the 25% overhead used for controlling and signaling. So now if we go further, okay, to know the real throughput, we need to consider what we call a modulation coding scheme. What is it? It's actually a modulation which takes into consideration the coding rate. The coding rate describes the efficiency of a particular modulation scheme. So for example here, if we are working with a 16 QAM, okay, so a 16 QAM normally carries 4 information bits, okay, but with a 0.5 rate means it can only carry 2 information bits, okay. So here an example of a modulation and TBS index table. TBS actually stands for transport block size. So in this table we can see, and this is for a previous LTE standard, for MCS index 0 until 28. Okay, we have an associated TBS index from 0 until 26. Okay, so what is modulation order? So for example here for 2, this is for QPSK. Okay, QPSK, and then you have for 16 QAM, and of course obviously the until here, and then you have the 64 QAM. Okay, the bigger the TBS index, the bigger throughput that we can have. So this is the maximum, okay, for 16 QAM, and this is the maximum for QPSK. Alright, so for example, in our case, we have 100 resource blocks. The maximum that we can have is actually MCS index equals to 28. So what is the TBS? Let's have a look. TBS index is 26. If we go here, 26, and with 100 resource blocks, the number of throughput or data rate is 75,376. Okay, so this is the throughput for 100 resource blocks. And assuming that we have a 4 times 4 MIMO, so the peak data rate needs to be multiplied by 4, and it becomes 301.5 megabits per second.